A structural steel plate 100 mm wide and 10 mm thick is to be welded to a steel plate by a parallel fillet weld, okay, by a parallel fillet weld, and has to carry a load of 20 kilonewton. Determine the length of each weld for static and dynamic loading so that maximum shear stress is not to exceed 60 megapascal. This is the maximum shear stress that it should not exceed. So we are given with structural plate of width, that is the value of B equal to 100 mm. Then plate thickness is 10 mm. So how it is 10 mm? I think I have explained you in the previous class. Okay. So when you look at the weld here, so weld says when they say that will be almost equal to the thickness of plate, right? So therefore it is 10 mm. I think I had explained you in the previous class. Load carried by this parallel fillet weld is 20,000 Newton. Maximum shear stress is 60 megapascal, right? So first let's look at for static loading. Shear stress is given by P by 0.707 W into length of parallel fillet weld. So substituting, we are going to get length of parallel fillet weld. After simplification, we get this. Then total length of the weld will be length of parallel fillet weld plus 5 times the number of free sides. So here, in case of parallel fillet weld, we have 1 free end, 2, 3, and 4 free ends we have got. So therefore, multiply 5 mm into 4, add to the length of parallel fillet weld, that will give you the total length of parallel fillet weld. We have taken it down up to this, or you have to take this?
So we have to start right now.
Yeah, it is done.
Yes, sir.
Okay. So now let us go to dynamic loading case. When you have dynamic loading or fatigue loading case, we need to find out stress concentration factor. So the stress concentration factor will reduce the allowable shear stress that is permitted to solve the problem, right now. So when you take the stress concentration factor, by definition, we know it is maximum shear stress by allowable shear stress. So now allowable shear stress will be equal to maximum shear stress by K sigma. So from where do you get the K sigma value for a welded joint? Now take table 6.3. Please go to table 6.3 of your data handbook. Please go to table 6.3 of your data handbook. Are you there?
Yeah.
Yeah. One of you please read the 6.3 table. Start from the beginning. Please read, one of you, what is that is present in the data handbook.
Reinforced butt weld, the stress concentration factor is 1.2.
Yeah.
Toe of transverse fillet weld, the stress concentration factor is 1.5.
Correct.
T butt joint with short corner,
Yeah.
stress concentration factor is 2.
Yeah.
And for end of longitudinal fillet weld, the
Is
stress concentration factor is 2.7.
2.7. Correct. So that is longitudinal or parallel fillet weld. So the value of K sigma is equal to 2.7. So the allowable shear stress will get reduced by that amount. So therefore your allowable shear stress will be maximum shear stress that is given in the problem is 60 divided by 2.7. So the allowable shear stress becomes 22.2 megapascal. Now we need to find out length of parallel fillet weld with shear stress of 22.2 megapascal. So therefore use the same formula of tau is equal to P of 0.707 W into length of parallel fillet weld. So again, you will get length of parallel fillet weld by considering dynamic loading. So when you look at the length of weld here, so when I consider it for dynamic loading, length of parallel fillet weld that I need to have is 147 mm, whereas for if I don't consider dynamic loading, it's only for static loading, what we need is only 67.17 mm, okay, 147 mm. is what is required for static loading. When it is dynamic loading, we need to have total length of rail to be equal to 147.3 millimeter. Could you get the difference between these two? Could you get the difference between these two?
So what value changed
When
from
it is
static to
subjected
dynamic?
to dynamic loading condition, see, I'll give you a best example. We have on roads rumblers. Have you seen white paint they have put? No. So everywhere they have put
Yes,
white
sir.
paint. Okay. So all of us happily we just ride it on that at the same speed. But those rumblers, okay, which will be called as time varying loading. Okay, that is dynamic loading. So the welded joints are subjected to severe loading condition out there. So therefore, the welded joints will come out. If you are riding scooters, if there are welded joints, definitely it's going to break after say 20 days or 1 month of running it on rumblers at a speed of around 60 kilometers per hour, right? So therefore, when you want to have strong joints, when you are riding it in dynamic condition, then we need to have more length of weld is what it all indicates. Is that okay? Is that okay?
Yes.
Because I have personally experienced that the scooter's stepney was welded to the, there is one bar at the back of it, along with the chassis to hold for the pillion rider. So for that it was welded. So after a month's running on these rumblers, that welded joint gave away. So then I realized these rumblers, so it is subjected to dynamic loading. And so therefore, when you have to sustain the welded joint for dynamic loading condition, then you need to have more length of weld. That is, you have to put more material into the system. That's it, right? Is that okay?
Yes, sir.
Yeah, please note down for dynamic loading, stress concentration factor is to be taken. So for that, refer table 6.3 in page number 94. Please note down this. If any of you have any doubt, please let me know.
Done, sir.
Yeah. Please note down. So finally, you can find length of each weld to be equal to 73.65 mm. That is this total length. Each of them will be 73.65 mm. I is total number of free ends. Okay, I is total number of free ends. So for a parallel fillet weld, we'll have 4 free ends over here. 1, 2, then this is 3, and this is 4. 4 free ends are there. Simple, the given stress comes down to, given shear stress will be reduced because of presence of K sigma, that's all. So we need to find out or repeat the same procedure, that is to find length of parallel fillet weld with reduced shear stress, that's all.
Sir, in the static
Yeah.
loading, we were using maximum shear stress only as our toe.
Yeah, maximum shear stress is 60 megapascal. Yeah.
Okay.
So when it is subjected to time varying loading condition, then the shear stress will have to be reduced. And we have to design the welded joint such that the allowable shear stress is only 22 megapascal. Then what will happen? We have to increase the length of the weld. That's it. That means we are increasing the stiffness by adding more material. That's it.
So in this, if the welding was done from 2 to 3, then there'll be only two free ends, no, sir?
Pardon me?
In this, if the welding was done from the free end 2 and free end 3, like if 2 and 3 were connected by a
2
weld,
and 3 were connected. That is called
and 1,
compound.
2, and 3, 4 were connected, then
Yeah,
there will
then
be
if 1 to 4 is not connected, you will have only two free ends.
yes.
Yeah, that's called compound fillet weld. Next problem is what is that only we are going to take. So you will have something like this compound fillet weld. So you will have only two free ends over here. Then I becomes 2 then.
Yes, sir.
Yeah. If you're finished, we'll go to the next problem. Please check the values. Please check the values with your calculator. Finished? We'll go to the next one.
Yes, sir.
Yeah, not on this problem. A 80 mm wide, okay, 80 mm wide and a 12 mm thick plate, 12 mm thick plate, a 80 mm wide and 12 mm thick plate is subjected to axial tensile load. A 80 mm wide and 12 mm thick plate is subjected to an axial tensile load axial tensile load is welded to a vertical support by a single transverse fillet weld and double parallel fillet weld. Okay, single transverse fillet weld and double parallel fillet weld. So if you look at this drawing here, if you look at the drawing here, this and this are parallel fillet welds, correct? Correct? And this is a transverse fillet weld. So you have one transverse fillet weld and two parallel fillet welds. All right? So therefore, it is single transverse fillet weld and double transverse fillet weld as shown in figure. The maximum tensile, because transverse weld is subjected to tensile stress. Okay, so the maximum tensile and shear stress in the welds are 100 megapascal and 70 megapascal respectively. So therefore, I have taken here maximum shear stress to be 70 megapascal, maximum tensile stress to be equal to 100 megapascal. Find the length of each parallel fillet weld if the joint is subjected to static and fatigue loading. Again, that is time varying load, that is dynamic or fatigue loading. Please note down this problem. Please underline that single transverse fillet weld and double parallel fillet weld. Noted? So the data, when you look at data, width of the plate is 80 mm. So that's going to be the value of P. So this is width of the plate, and that is to be taken as value of B. Okay? And 12 mm thick plate. So therefore weld size is 12 mm. W will be 12 mm. Maximum shear stress is 70 megapascal. Maximum normal stress is 100 megapascal. So for static loading, because we are not given with the value of P there, right? So therefore, for static loading, sigma is given by P by A, that is P by B into H. So that will give us the total load shared by the welded joint. This total load will be equal to sum of normal load and shear load. Okay, that is load because of parallel fillet weld plus load because of transverse fillet weld. So we have for normal fillet weld given by 0.707 W into length of normal fillet weld into sigma. Similarly, for shear stress, we have 0.707 W into length of parallel fillet weld into shear stress will give you total load, right? So from total load, calculate length of parallel fillet weld, and total length of weld will be, you will have two free ends. So you will have two free ends. So therefore, length of parallel fillet weld plus 5 into 2 will give you total length of the weld. Is that okay? Are you there?
Yes, sir.
Yeah, please note down. The total load is shared by between, or is taken up by normal, transverse fillet weld and also parallel fillet weld. So therefore, the total load P will be equal to load shared by transverse fillet weld plus load shared by parallel fillet welds. Please note on this. Then we'll go to fatigue loading. Meantime, answer your roll call. 1.
Answer.
2. 3. 4. 5.
Yes, sir.
6.
Present, sir.
7. 8.
Present, sir.
9. 10.
Present, sir.
11. Biban. 12.
Present, sir.
13.
Present, sir.
14.
Yes, sir.
15.
Present, sir.
17. 18.
Present, sir.
18.
Sir, 17 present, sir.
17%. 18. 19.
Present, sir.
20.
Sir, 19 present, sir.
Hey, okay, man. I'm calling 20. I say 21.
Sir, 20 present, sir.
Where were you, Purushottam Reddy? Running around.
Sir, network lagging, sir.
Okay. 21. 22.
Present, sir.
23.
Yes, sir.
24. 25. 26. 27. 28. 30. 31. 32. 33.
Present, sir.
Narendra Haryala.
Ullas, sir.
Only all. 34,
Yes, sir.
35, 36, 37, 38, 39.
Yes, sir.
Prajwal,
Yes, sir.
where were you for last 5 classes?
Sir, I was not feeling well.
What happened?
Sir, fever,
Then,
cold, sir.
what did you do for that?
Sir, was taking rest, sir.
What rest? No tablets, huh?
Yes, sir, I took tablets, sir.
What tablets did you take?
Sir, the doctor prescribed.
Yeah, doctor gives you tablets. I say, what is the name of the tablet?
I don't know, sir.
You don't know. Are you an educated fellow?
Yes, sir.
Huh? If the shop fellow, medical shop fellow gives some other tablet, what you will do, man?
Sir, it starts with M, sir. Something I don't know, sir.
Starts with M.
Yes, sir.
Prescription you don't read, huh? Whatever doctor gives,
He can't
don't-
understand.
huh?
He can't understand what he writes, sir.
You have to ask what is the name of this tablet.
Okay.
If instead of stopping loose motion, if the shop owner fellow gives for more loose motion, what will happen to your condition, man? Correct?
Sir.
You should look into all these things, or you are bluffing simply. Either of the, which
Not
is
bluffing.
correct. Okay, 40.
Yes, sir.
41, 42,
Yes, sir.
43,
Yes, sir.
44,
Present, sir.
46, 47,
Yes, sir.
48,
Yes, sir.
49, 50,
Yes, sir.
52, 53,
Yes, sir.
54,
Yes, sir, present.
55, 56, 57, 58, 59, 60,
Yes, sir.
61,
Yes, sir.
61. Vinay J.
Yes, sir.
Where were you for so long? Where were you, Vinay? Hello, you have to talk, man.
Yes, sir.
Where were you? I'm asking you.
I wasn't feeling well, sir.
Huh?
I wasn't feeling well, sir.
For how long? Last class you attended was on, you remember when? 29th of September is the last class you attended. Now we are come on November 17th. You were not well for 1.5 months.
Sir, last week I attended, sir.
Huh?
I attended last week, sir.
Last week, which class you have attended? You are not present now, only today. Had you gone for maternity leave? Huh? Vinay,
No, sir.
were maternity leave or paternity leave? Which leave you had gone? Where are you, Vinay? Where is your place?
Bangalore, sir.
Bangalore only.
Sir.
Where do you stay in Bangalore?
Yashwantpur, sir.
What you are doing, I say, without attending for months? Pipan Singh? Vivek?
Present, sir.
Milan Chaudhary? Mulepati?
Present, sir.
Saksham Singh? Chaitanya?
Yes, sir.
Mahesh? Nishant? Ramesh?
Present, sir.
Ramesh, present?
Yes, sir.
ಏನ್ರಿ ಇವತ್ತೇನ ಫಸ್ಟ್ ಡೇ
ಎಸ್ ಸರ್.
ಹಾ, ಯಾಕೆ ಎಲ್ಲೋಗಿದ್ರಿ?
ಸರ್ ಇಷ್ಟು ದಿನ ಊರಲ್ಲಿದ್ದೆ, ಮೊನ್ನೆ ಬಂದೆ ಸರ್.
ಹೌದಾ?
ಹ್ಞೂ ಸರ್.
ಓಕೆ. ಆರೋಗ್ಯ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಂಡಿದ್ದೀರಾ ಊರಲ್ಲಿ? ಒಳ್ಳೆ ಗಾಳಿ
ಹ್ಞೂ ಸರ್. ಫುಲ್ ಫಿಟ್ ಸರ್.
ಎಂಜಾಯ್ ಮಾಡಿ. ಶಶಾಂಕ್, ಅಕ್ಷತ್,
Present, sir.
ಸೌತ್ರಿಕ್ ರಾಯ್, ಮಹಿಮಾ,
Present, sir.
ಶ್ರೀವತ್ಸ,
Present, sir.
ಸುಮನ್ ಜೇವಿಯರ್, ಮದನ್ ಕುಮಾರ್, ಮನು, ಶದಾಬ್, ಗಣೇಶ್.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಗಣೇಶ್ ಅವ್ರ ಪ್ರೆಸೆಂಟ್?
ಹಾಂ ಸರ್.
ಏನ್ರಿ ಎಲ್ಲೋಗಿದ್ರು ಲಾಸ್ಟ್ 6 ಕ್ಲಾಸು? ಏನ್ ಅಟೆಂಡ್ ಆಗ್ತಿರ್ರಿ? ಏನು ಪ್ರಯೋಜನ ಇಲ್ಲ, ಇವೆಲ್ಲ ಏನು ಯೂಸ್ ಆಗಲ್ಲ, ಸುಮ್ಮನೆ ಅಷ್ಟೇ. ವಿಜಯ್ ಕುಮಾರ್, ರಿಷಿ ಎಸ್, ಜಾಹಿರ್ ಹುಸೇನ್.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Yeah, go to the next page. Come to fatigue loading here. Okay, so in fatigue loading, we need to find again the stress concentration factor K sigma. So as we have seen in that, K sigma is equal to 2.7 for parallel fillet weld. So from table 6.3, and for normal fillet weld, that is toe of transverse fillet weld. And that is nothing but normal fillet weld, for which K sigma is equal to 1.5. So what will happen to allowable shear stress? With K sigma is equal to 2.7, allowable shear stress becomes 70 by 2.7. So that will be 25.92 megapascal. And for K sigma is equal to 1.5, the allowable normal stress becomes 66.67, because 100 divided by 1.5 will give you 66.67. So we need to find out length of parallel fillet weld with reference to the new allowable shear and normal stresses. Okay, so substitute in the same equation that we have taken, that is total load is equal to load shared because of normal fillet weld plus load shared by parallel fillet weld, that is P is equal to P normal plus P shear. So note down the equation for normal and shear stresses, and then get the value of parallel fillet weld length, and find out total length. So please note down this solution. Please note down. Vinay J, are you there? Vinay J. Once you have finished, please let me know. Make it fast.
Just a minute, sir.
Yeah. Please understand while noting down blindly, don't copy from the screen. All right. So please understand, if you get any doubt, please let me know.
Yes, sir.
Done. Anybody needing more time to note it down? Yeah. Next topic. So with that, we end up with problems which are based on axial loading cases. Okay. So we solve problems based on the welded joints being subjected to axial loads. Now let us look at the welded joints being loaded with transverse loads, and they are called eccentrically loaded welded joints because in practical situations like structural joints, the externally applied force may not pass through geometric center of the weld. So such joints are called eccentrically loaded welded joints. So this is how an eccentrically loaded welded joint look like. Load is acting in transverse direction, and this is the CG. This distance is called N. This distance is taken to be M, and whatever that you see here, that is the location of center of gravity. This is center of gravity of the weld. Okay, so Ny will give you the distance of CG from the weld or transverse weld over here, and this distance of the parallel weld with from CG is taken as E, and the distance from CG to the point of application of load is taken as eccentricity, denoted by E. Is that okay? This is E there. So note down the sketch and note down this definition. In practical situations like structural joints, the externally applied force may not pass through the geometric center. Such joints are called eccentrically loaded welded joints. So here the load will act in transverse direction. E is called the eccentricity, that is the distance from CG of the weld to the point of application of load. M is the width over here, N is the distance over here, Ny will give you the CG, okay, location of CG from transverse weld over here. And this is R. R is radius of the weld, theta is the angle. Is that okay? So please note down the sketch and the definition into your notebook. M is vertical distance or the length of transverse fillet weld. N is length of parallel fillet weld. Please note down the sketch clearly. R is radius over here. This is theta. This is CG. Noted?
1 minute.
Yes, sir.
Yeah. This distance is eccentricity. This is Ny. Okay.
So what is the part after ny?
N1
N1.
is N suffix 1.
Okay. Done, sir.
Yeah. Please go through whatever that is done, whatever that you have taken, the sketch that you have taken, please go through. Let's look at the procedure. Please keep your sketch along with you. Yeah. So this can be solved by a procedure, adopting a procedure. Find out total length of the weld. Total length of the weld is nothing but N plus M plus another N over here. Okay. So when you have weld like this, say suppose if you have weld like this, so only you will have N and M. Okay. So the total length of the weld will be N plus M. But in this case, it's going to be N plus M plus again N. Is that okay? Is that okay? That will give you the total length of the weld L. All right. Now, direct load per unit length that is given by PD is equal to P by L. Okay. This is L. So this is P by L will give you direct load per unit length. That's why the unit is Newton per millimeter, right? So this L is nothing but total length of the weld. P is nothing but the load that is acting over here, right? So this P by total length of the weld will give you load taken up by every millimeter of weld over there. That is what is called as direct load per unit length given by PD is equal to P by L Newton per millimeter. That is a load shared by every millimeter of weld is given by PD. Next, locate CG, center of gravity, NY. Take table 6.7 in page number 96. Take out your data handbook. Take out your data handbook. Go to page number 96. Are you there at page number 96?
Yes, sir.
Yeah. So at page number 96, table 6.7, okay, look for the value of Ny. On the left hand side, what you have is, what is that you have here on the left hand side? Page number 96, not 97, page number 96. On the left hand side of the column, what is there on the top? Can anyone let me know?
Type of weld.
Type of weld, okay. Next column is section modulus in bending, correct? Correct?
Yes, sir.
And the last one is polar moment of inertia in torsion. That is J value. Okay. So when you come down to the last in type of weld, all right, what is the value of Ny given over there? Can someone read out?
So n square by 2 into n plus m.
2 of n plus m. Okay, so only small correction is there. When we take up the, it is not 2 of n plus m, it is 2n plus m. Please make correction in your data handbook over there. It is 2n, that is 2 into n plus m. It is not 2 of n plus m. Is that okay? 2 is multiplied only to n and not m. So in the last one, please change in your data handbook. All right. So using table 6.7 formulae in page number 96, calculate or locate or calculate the location of center of gravity Ny. Is that okay? Then find eccentricity. Once you know the value of Ny over here, so then you will get the value of eccentricity, okay, if the total length is given. Otherwise, in some problems, they'll give eccentricity directly. In some problems, they'll give total length of the from point of application of load to the edge of the weld, they'll give like this. So in such case, subtract Ny from here, then you will get the value of eccentricity. Is that okay? So get the value of eccentricity, cos theta, and find out R, which is given by, in this case, root of N1 square, right? This is N1. So before that, you find out N1, that is N minus Ny. N minus Ny will give you what? N minus Ny will give you what?
N1.
N1. Okay. So N minus Ny will give you the value of N1. All right. So therefore, from the Pythagoras theorem, R is equal to square root of N1 square plus M by 2, because this distance is going to be M by 2, correct? In this case, correct? So this distance is M by 2. All right. So therefore, R is equal to root of N1 square plus M by 2 square will give you the value of R. Are you there with me? Are you there with me? The square root symbol is fully like that. It is, right? Next, find out polar moment of inertia. Okay, in torsion from table 6.7. So go to same table. You have got the polar moment of inertia in torsion. Okay, so if you look at the third column, you have got J is equal to 2n plus m whole cube by 12 and so on. In that case, I have given a note over here. Ignore HT value in the beginning, right? While calculating JW, ignore the value of HT over there, because that will be that we are going to get it as weld size at the end. So while calculating JW, ignore the value of HT. Are you with me? Are you with me?
Yes, sir.
Yeah. So next is twisting moment per unit length given by Pn, that is equal to P into E into R. P is the load, E is eccentricity, R is radius of the weld that we find out at this stage. JW we would have found out in the previous step. So substitute them, get the value of Pn, then get the resultant load PR given by under square root PD square plus Pn square plus 2PD into Pn into cos theta. Okay, right? So then find the shear stress is given by PR by 0.707 W. So from that we can get the value of size of weld. So if you just follow these steps, you will get the required parameter in the given numerical. Is that okay? Are you there? Note down this. Note down the design procedure. Note down the design procedure into your notebook. Is it visible? Clarity is there for you people?
Yes, sir.
Fine. This W is a small w. So sometimes I use a star here for multiplication. Sometimes I use into mark, small x over there. Okay, so don't get confused. So this n1 square plus m by 2 square is only specific to a compound fillet weld like this, right? So it will vary for different types of welds. It's only a representative equation that I have given over here. This is only for compound fillet weld. So if the type of weld changes, then this value will change. So don't use this value. Okay. Refer table 6.7 for calculating our value of, it will vary depending upon the type of weld. Okay. So do not take this. This is applicable only for a compound fillet weld, which is like this. Finished, Did you finish?
So for other days, from which table should we take?
Which one?
You said
No, it is not from table. It is depending upon the weld, the value of n and m will change. So from there, we are going to calculate the value of radius.
The equation will remain the same, no, sir?
Let's see how it will be in other cases. Say, for example, when you have case like this, right? So you will have mx here. So essentially, what we need is distance of this distance plus this distance. Okay. So
Yes.
sometimes if the weld type changes, this value of m by 2 should not be taken. Okay. So it's only a representative equation. So better not to take that equation.
Okay.
Finished?
Yes, sir.
Akram Anwar, are you there?
Yes, sir.
Akram, can you please read the steps one by one? Others, please look into your notebook.
The total procedure of weld is I.
No, no, no.
Sorry, sir.
It is not total procedure. It is total length of weld.
So it is somewhat blurry here, sir.
Is it? For you, it is blurred.
Yes. Yes, sir, somewhat blurred.
Is it?
Yes.
You're in mobile phone, is it?
No, sir, laptop, sir.
Laptop.
I cannot zoom.
No, you have
I
not
cannot
noted down, huh?
I have noted down, sir. I'll read it out.
Okay. That's total length of weld L. The next,
Yes,
next what?
Direct load or unit length PD is equals
Per
to
unit length is direct load per unit length. Yeah.
Per unit length PD is equals to
P
per ln per
no,
millimeter.
P by L.
P by L
per millimeter is the unit. Yeah.
Okay.
Next.
Locate CG, which is NY, referring T 6.9, page number 96.
Table 6.7.
Table 6.9.
Table 6.7, page 96.
Page number 96. Find eccentricity E cos theta R is equals to square root of N1 square plus M by 2 whole square.
Okay, next.
Polar moment of inertia in torsion, JW, table 6.7, page number 96.
Okay.
Note, ignore HT value while calculating JW from table 6.7, page number 96.
Fine, next.
Twisting moment per unit length, Pn is equals to P into E into R whole divided by JW.
Okay.
Resultant load PR is equals to square root of PD square plus PN square plus 2 PDN into PN. PD into PN. PD into PN cos theta.
Fine.
Again, shear stress tau is equals to PR divided by 0.707 into W. W is equals to size of weld.
So from shear stress equation, we are going to get the value of W. Correct?
Yes.
Correct?
Yes.
Others, have you got clarity? Any doubt in this? Okay. So please practice this. Yeah?
No doubt, sir.
Fine. Practice this procedure. So tomorrow, this next class, we'll start with problems in this eccentrically loaded welded joint. Fine? Okay?
Yes, sir.
All right. Okay. See you in the next class.
Yes, sir.
Yeah.
Thank you, sir.
Yeah.